All right, so another question that was coming up quite a bit was about the polar form of complex numbers. So this will be the first video where I just talk about what the heck does polar form mean. And then in the second video, I'll talk about why we can use our RE to the I theta format. And you can watch this first video where at any time, but if you're going to watch that second video, you need to go back and watch the Maclaurin series videos on e to the x, on sine, and on cosine. It's not going to make sense without that background knowledge of what a Maclaurin series is for e to the x, sine, and cosine. So, but before we get into that, the whole idea behind a complex number is that you can represent it as a point in the plane. And so for right now, I am just looking at the complex number 2, 4. And really, I'm calling it a point, but you're probably more familiar with thinking of that as 2 plus 4i. But I hope you can see how any complex number can be easily changed into a point by just making the real part of the number the x value and the imaginary part of the number the y value. The reason why I have this black segment there is to demonstrate the idea of r. R is the length of that segment right there. So when we talk about the polar form of a complex number, one thing we're talking about is just how far away from the origin is that number. And so you can draw a nice right triangle with that, and then you can say your x value and your y value make your r value. X squared plus y squared equals r squared. For our particular example, I would just be saying 2 squared plus 4 squared equals r squared. So r is going to be the square root of 4 plus 16. Square root of 20 is r. If you want to reduce that down, you can reduce that to 2 root 5. Okay? So that is one way of talking about the complex number 2 plus 4i, is saying, oh, well, it is a distance from the origin of 2 root 5. And in fact, if I type that into Desmos, if I say r equals 2 times the square root of 5, you'll see it creates a circle. And so the reason I draw the circle is that there's an infinite number of complex numbers that all have a distance from the origin of 2 root 5. So how do I distinguish my specific one? Well, I talk about the angle. And so we usually use the letter theta for angle. And so theta is defined just like on the unit circle. Theta is defined as the angle rotating counterclockwise, and a 0-degree angle or a 0 radian angle is pointing due east. So how can you find that? Well, I know I can use sine or cosine or tangent. I suggest using tangent because when you have a complex number, you know the opposite and adjacent sides. Those are the real and the imaginary part. So I know that the tangent of theta is y divided by x. It's the imaginary part divided by the real part. And so in this particular example, I would say the tangent of theta is 4 divided by 2. The tangent of theta is 2. And that tells me that my angle is really the inverse tangent, or some people like to use the word arctangent, the inverse tangent of 2. And so then if I want to talk about this complex number, I can either give you the rectangular coordinates, you go 2 steps right and 4 steps up, or I can give you the polar coordinates, where I say you go 2 root 5 away from the origin, and you rotate an angle of the inverse tan of 2, the arctan of 2. Okay, let's do one more quick example here. Let's just change our initial point to something else. Um, let's just say we have a point over here. Okay, well, no, I just used those values. Let's try a point over here. So I know this one has an x and a y value of -3 and -3. The distance to the origin can be found with this right triangle where you have a -3 and a -3. So r squared equals 9 plus 9, because that's 3 squared. So r is going to be the square root of 18. R is going to be 3 square root of 2. 3 square root of 2. And then the tangent of theta is going to be -3 divided by -3. So the tangent of theta is equal to 1. So theta is the inverse tangent of 1. However, you got to be careful. On the previous example, my angle was in the first quadrant, and so inverse tangent works. It gives me the correct value. But here, if I actually did the inverse tangent of 1, like on a calculator, it would tell me a 45-degree angle, or pi over 4. But we can clearly see that this is in quadrant 3. And so we would want to take our angle here and just add pi to it. And so our theta value is going to be, I guess, 5 pi over 4. But the point of this video is just that any rectangular coordinate can be changed into a polar coordinate by using the Pythagorean theorem to get the distance from the center, and using tangent to get the angle from the x-axis. And that's it. Once you watch this video, go on and watch the next one about how we can represent complex numbers using r(e) to the I theta format. And make sure, if you do want to watch that video, make sure you watch the ones about the Maclaurin series for e to the x, for sine of x, and for cosine x first. All right, thank you.